Today we'll be doing the 2020 WACE physics exam. I'm just gonna get my formula sheet out. And then we'll get started. Bada boom. Formula pages out, get my calculator, 3 hours on the clock. Ready to start, let's go. From the first page. A ball is launched vertically into the air with an initial velocity at t0 from ground level and returns to the ground. It takes 4 seconds for it to reach its maximum height. Taking upward as positive, graph the ball's displacement, velocity, and acceleration. That's just time. Okay, so acceleration is just going to be a straight line, negative. Velocity is going to be initial velocity, and then at 4 seconds it reaches its maximum. So we're going to pass through 4 and something like that. And then displacement will be about there. Wait. Vertically into the air. So yeah. Maximum height at 4. And then coming back down for 8. There we go. Calculate the speed of an electron with a de Broglie wavelength of 1.23 nanometers. So that's the wrong thing. Lambda is equal to hc all over p. Wait, no, it's just h over p, isn't it? Yeah, h over p. We want electron, so it's equal to h over mv. So then velocity is going to be equal to h over m lambda. Here you go, 6.63 times 10 to the negative 34 all over 9.11 times 10 to the negative 31 times 1.23 times 10 to the negative 9. And now, simply putting this in my calculator. Just gonna smash it for a second because it wasn't turning on. I have this problem with this calculator, I think because I've had it for a while. Sometimes the screen goes a bit odd. And then it doesn't want to like turn on, so I have to like hit it a few times. So it's 5.92 times 10 to the power 5 meters per second. A 10-watt monochromatic LED radiates with a wavelength. How many photons does it emit per second? Assume all energy is converted to light. So 10 watts equals 10 joules per second. And a wavelength of 500 of 25. So H equals, or E equals H over lambda. Which is equal to 6.63 times 10 to the negative 34. Times 3 times 10 to the power 8. So essentially I'm going to find out how much energy is in one photon, and then divide that by divide 10 by that to find how many seconds. So 6.3 times 525 times 10 to the negative 9, because it's in nanometers. So here we go, I am so sick of writing 6.63 times 10 to the negative 34. 525. Where's the electromagnetic questions? 3.7886. 17 joules. So then how many photons does it emit per second? To get per second, I need to divide 10 by, maybe I should do number of electrons or photons is equal to 10, 3.7886 and to negative 19. If you can't figure this out, you just have to look at the the units, and you'll see that these joules will cancel and we'll be left with some value of per second, which is going to be the number of photons. And I get that this is 2.64 times 10 to the power 19 photons a second. So 2.64 times 10 to the power 19. Just make sure this wasn't like an estimate or something. So, in a physics experiment, a group of students run a DC motor current upwards along a 3.5 vertical wire. Calculate the magnetic field strength to 25.1 centimeters from the vertical wire carrying a current of 2.78. So an F is just going to be equal. I think this is ILB. Let's make sure. Magnetic force in the current carrying conductor. Yep. So my current is 2.78. My length is 3.5. And then my strength. Wait, this isn't right. Magnetic field strength, not the magnetic force. This is actually B is equal to UO all over 2 pi times I over radius. This is just going to be, I think it's 4 pi times 10 to the negative 7. So divide by 2 pi. 2 times 10 to the negative 7 over 2.78 over, wait. Calculate the magnetic field strength. Yeah, no, I think this is right. Over radius at 0.25, 251. .78 0.251. This is 2.22 times 10 to the negative 6 Tesla. When looking from above, which of the following shows how the magnetic field around the wire correctly? So upwards, so the current's going upwards on the vertical wire, and I'm looking from above. I think it's going to be A. It decreases with radius, and at the right hand side it's going to be going upwards. It's not C or B, and it has to be decreasing in strength, which is why it's further apart than D, where it's all equally spaced. So A. Here stands 20 centimeters from the end of a 5.2 long uniform diving board. Calculate the upwards forces the support must exert on the 50 kilogram board for the system to remain in equilibrium. Okay, so let's take the moments around P. Thank God that this talk question is going to be a bit simple. We just have that the sum of the anti-clockwise is equal to the sum of the clockwise, and the sum of the anti-clockwise is just going to be the reaction force of the support. So let's say F of support. Yeah, back. My mom just came in. So it's the force of the support, and then the radius is 2 meters. So then we know that the sum of the clockwise is going to be equal to, let's do the mass of the diving board first. So 9.8 times 50 times half of the length, which is 2.6, plus 9.8 times 40 times 5 meters. So this is equal to 50 times 2.6 plus 40 times 5, 3,234 Newton meters. So then 2 F support must equal 3, 2, 3, 4. So then F support is going to be equal to 1.62 times 10 to the power 3 newtons. Yeah, looks all good. Calculate the electric field strength 2.25 times 10 to the negative 3 from a point charge of 4 times 10 to the negative 18 C. So field strength is just going to be QV over D. E is equal to voltage times D. So E is equal to F over Q. So it's going to be 1/4 pi E naught times Q over R squared. So 1/4 pi times 8.85 times 10 times 10 to the negative 12 times Q, which is 4.0 times 10 to the negative 18, and then this is 2.25 times 10 to the negative 3 squared. So then we have 1/4 pi 8.85 times 10 to the negative 12 times, oops, some poor formatting, so 8.85 10 to the negative 12 times 4.0 times 10 to the negative 8, or 2.25 times 10 to the negative 3 squared. Is this correct? I get a massive family. Hold on a minute. Oh, negative 18. That's why. I just need negative 8. Oh, and I'm going to have to pause because I forgot to put my timers on again. Give me a second. So, making that, now I get that 7.10 times 10 to the negative 3. This is newtons per coulomb. 7.10 times 10 to the negative 3. Connect. How many? When does section 2 start? Section 2, section 2. Does section 2 not start? What? How many? 53 marks. No, section 2 starts here. Where was I? Here. Students in a physics laboratory launch plastic discs across an aluminum air table. Air is blown vertically through small holes in the surface of the table, allowing the disc to float above the surface of the moon. This is a nearly frictionless environment, and the discs barely slow down as they cross the table. The students then attach a small but strong magnet on top of a disc and repeat the experiment. The disc slows down quite quickly, even though there is still no contact between it and the table. Explain why the disc with the magnet slows down quickly. Plastic disc across an aluminum air table. Okay, so as the disc with a magnet moves, it generates change in flux for the aluminum table. And then we can say by Faraday's law, where phi dt equals the EMF. This induces an EMF slash eddy currents in the aluminum table. And we can say by Lenz's law, these will in such a direction so that the magnetic field produced from the induced EMF will oppose the change in flux that created therefore will provide a retarding magnetic force against the permanent magnet on the disc, therefore slowing it down quickly. Oppose the change in flux that created it, therefore provide a retarding magnetic force against the permanent magnet on the disc. It will be in such a direction therefore firing force as the magnetic fields interact. Slowing it down quickly. The student deduced that the retarding force on the disk of the magnet is proportional to the speed of the disk. Which set of velocity and acceleration versus time graphs best describe the motion of the disk with the magnet? Velocity. So you want velocity to be decreasing. So not these. So not this. Then obviously we want acceleration to be negative. So it's probably B. Because the retarding force is proportional to the speed of the disk. So yeah, here velocity is like the lowest, but then acceleration here is the highest, which doesn't make sense. So yeah, it's definitely B. The diagram shows that when monochromatic coherent light is shown through two narrow slits on the screen, light and dark fringes appear on the screen. What property of light causes this to happen? Standard to wave. Explain how both the light and dark fringes are formed. So as photons pass through the narrow bands or narrow slits, they behave like waves and diffract, creating circular wavefronts. Wavefronts as they exit the band. And we can say these then these wave fronts, then interfere with each other. Let's put in brackets here wave fronts from the other slit. And can constructively or destructively interfere. And then we'll say light fringes are correspond to constructive interference. And dark fringes are areas regions of destructive interference. I think that's probably all I have to say. Maybe I'll say here with brightest in the middle. As path difference is 0. Difference is 0. Dark fringes are destructive interference, and I would say these alternate to each other. Alternate between each other. Okay, Lorentz transformation equation for the total relativity mass can be simplified to that. With reference to y versus v over c, and the equation explain why it's important for any particle of mass to achieve the speed of light. And this is 4 marks. So as v approaches c, then square root of 1 minus v squared over c squared approaches 0. This causes a incredible and extreme increase of energy required to achieve the speed, as E is inversely proportional to, let's say, so you can just see that. Hence, the Lorentz transformation approaches infinity. Z is proportional to that. If V equals C, required energy will be infinite. For a particle with mass. Hence impossible particle with mass. to travel at sea as it would require infinite energy. As it would require infinite energy. Okay, a golfer hits a ball 37.7 meters at 31 degrees. This is the last question. There's one more. Okay, to the horizontal on a flat fairway. It travels 123 meters. She wants to hit the target 135 meters away, so she increases the angle at which she hits the ball without changing the launch speed. Calculate the smallest increase of angle that will allow her to reach the target. Okay, she wants to hit the target 135 meters away. So she increases the angle at which she hits the ball. So then she wants that, so let's go horizontal. She wants that S equals 135. And then she wants 135 equals 37 cosine theta t. And then for vertical, let's say that the time spent is going to be 2. So let's say 2 maximum. S is equal to 37. Oh no, I can say that V equals 0. To maximum, V equals 0, therefore 0 is equal to 37 sine of theta minus 4.9 of t. So then t is equal to 37 all over 4.9 sine of theta. So then whole trip, t is equal to 2 times 37 4.9 sine of theta. Then plugging back into horizontal, so t into horizontal. We now have that 37 times, so I now have 2 times 37 times 37 over 4.9 sine of theta cosine of theta must equal 135. And then I've lost these zeros, so it's going to be 2 minus 4t. Okay. And then this is where the 2 sine theta, so this is going to be 37 squared over 4.9. And this is going to be sine 2 theta. It's going to be equal 135. And then sine 2 of theta is going to be 135 times 4.9 divided by 37 squared. 4.9, 37 squared, which is 0.4832. So then 2 theta is equal to sine 4832. You could have, I did something wrong, because I get this. inverse sine of this is 28.89. If I divide that by 2, voltage is going to be less than 30. So she increases the angle at which she hits the ball without changing the launch speed. H cosine of theta. So 135 is equal to 37 cosine of theta times time, because there's no acceleration. And then to maximum, my velocity is 0. So I have 37 sine of theta minus, oh, not 4.9, that's just 9.8. Minus 9.8 t. Because I was thinking of the half AT squared, so S equals, but that's wrong. So this should just be 9.8. Okay, now let's do this. So 135 times 9.8 divided by 37 squared is 0.9664. So inverse sine of 0.9664 is 75.12 to 11. So the theta is going to be equal to 75.11 divided by 2, which is 37.56 degrees. So therefore, delta theta is just going to be equal to 37.56 minus, oh, my timer stopped. Okay, I'm gonna come back and see how long that was, and then I will be back and I'll put the timer back on and I'll take the amount of time. Okay, it looks like I was only gone for about a minute, so I'll make this 2800 and hopefully that'll make up for it. So we're gonna continue. So it's 37.56 minus 31, which is equal to 6.56 degrees. 31, 6.56 degrees. Excellent. Jake is lifting 2 blocks of mass, 1 kilogram and 2 kilograms respectively. The lighter book sits on top. The heavier one, and each of hands can exert a vertical force of 16.2, shown in that diagram. What is the magnitude of acceleration of the books? So we'll say F net is going to be equal to, actually let's say let up be positive, and we'll say F net is going to be equal to 2 times 16.2 minus 9.8 of 1 plus 2, because that's the weight force of the box. So this is 16.2 minus 9.8 times 3. So I have F net is 3 newtons. So then 3 is going to be equal to my mass times acceleration. So acceleration is just going to be 3 over 3. So it's just 1.00 meters per second per second. Because the mass of total is 3 kilograms. What is the magnitude of the force that the 2 kilogram book exerts on the 1 kilogram book during this acceleration? So we're gonna have, let me think about this. So there's going to be some reaction force, and then there's also just the force of it moving. I think so. So the magnitude of the force, so we'll say F net is equal to a force of reaction plus mass times acceleration. So this is going to be 9.8 times 1, because we're just using lighter book, and then 2 times 1, so this is going to be 11.8 newtons. The magnitude of what? And this makes sense because the 1 kilogram book is pushing down with 9.8. So we push back with 9.8, and then since this guy is accelerating because he's part of the whole structure, this book must be the one that's providing that force. So I'm pretty happy with 11.8 newtons. And then again we'll say let up be positive. Okay. Exchange particles gauge bosons mediate interactions between elementary particles such as quarks and leptons. Actually, wait, hold on. Let me think about this for a second. Go for it. So the net acceleration is 2 times 1, so it's 2 newtons. F of r yeah, because I have to add 9.8 anyway. Okay, sorry, I'm back. Have different fundamental properties. Choose the appropriate combination of relative fundamental force and property from your table below that corresponds to the gauge boson listed. Place the number of your choice in the space provided. So gluon is the strong nuclear force, and gluons, let's see, I don't think gluons have mass. Gluons are massless, so number 1. Photon is electromagnetic, and they also don't have mass, so 5. Said boson is the weak nuclear, and it has mass, so it'll be 4. And W boson is in the same boat, so 4, and it has mass. Which of the fundamental forces below has the longest range of interaction? What would be the electromagnetic? Because that has infinite range, just like with what's it called? Gravity, the graviton. Because strong nuclear only works pretty much within a nucleus, and a weak nuclear only works between particles. So that's the end of section 1. In an experiment to measure the charge of an electron, a student creates many tiny oil drops and allows some of them to enter the space between 2 horizontal plates that are connected to a variable voltage supply. A diagram of the apparatus is shown below. Initially, there is no potential difference in the speed, and the student chooses an oil drop and using a microscope watches it as it slowly falls, measuring its speed. The speed is constant at that. Okay, so there's no potential difference, and it falls. The speed is constant. The speed is constant, that means there's no acceleration, so I'll say that there is a force of gravity along with a air resistance. Force of air resistance. Because we're not like in an evacuated chamber or anything. It will be roughly equally, so yeah. Using the speed of the oil drop and other known quantities, the student calculates the mass of the oil drop as that. The oil drop is exposed briefly to radiation and it captures 1 or more electrons and hence becomes negatively charged. The student turns on the voltage supply and adjusts the potential difference between the upper until it stops moving. The potential difference is now. Name the 2 forces now acting on the oil drop. So oil drop stopped moving, so there's the electric force. 2 forces. So we have weight force, and then electrostatic would just be the electric force. I'll call it the electromagnetic. Let's say electromagnetic. Field strength. No, I think I should say electrostatic. Because the top is a positive plate. If the plate separation is 7.11, what is the electric field strength experienced by the oil drop? That is equal to voltage over D, and my voltage is 346. My distance is 7.71 times 10 to the negative 3. 7.71 times 10 to the negative 3. So I get 4.49 times 10 to the power 4 volts per meter. 449 times 10 to the power of 4. Calculate the electric charge of the oil drop. So Fg must equal F of E. So then Fg is equal to 9.8 times 6.86 times 10 to the negative 18. Nope, 16. 6.86, 10 to the negative 16. 6.7228 times 10 to the negative 15 newtons. So my electric force is going to be equal to 6.7228 times 10 to the negative 15. So then F equals QE. I'll say that QE equals 6.7228 times 10 to the negative 15. So Q 6.77228 times 10 to the negative 15 all over 4.49 times 10 to the negative 4, or 10 to just to the power of 4. Looks like we only have a few electrons, so because that 10 to the negative 15 divided by 10 to the power of 4 is going to be 10 to the negative 19. Power 4. Oh wait, I need to put 10 to the negative 15 here. So this is 1.4 or 1.5 minus 10 to the negative 19 coulombs. Did I do this all correct? Oh, 6.88. Brother. 6.88 times 10 to the negative 16. 6.7424. 1424 into negative 16. Voltage, which is 346 millimeters. Okay. Divided by 4.49 divided by 10 to the power 4. Okay, which is still 7.50. 1, 2, 3, 4. 4.49. Okay. The student repeats the process on the trials for different oil drops, possibly carrying different number of electrons. Calculate the charge of each drop. What does the student estimate the electron charge most likely to be? So am I just supposed to take the average of these? Assume the electron charge oh wait, no, so because these are like, since you can think that they are carrying different amounts, then that's like a 1.5 increase, that's another 1.5. So I'll just put 1.5 times 10 to the negative 19. Okay, muons and anti-muons are unstable. I don't, okay, back to this one, sorry. I don't just average these, because that's not the electric charge of an electron, that's like the average charge of these, and these could have different number of electrons. So I need to find like the common difference between each, which is roughly some multiple of 1.5. Muons and anti-muons are unstable. The decay process is producing 3 particles. When an anti-muon decays, one of the particles is an electron neutrino. Complete the table and use your answer to identify the missing particle X. So X has to have a +1 charge there, and a -1 charge there. So electron charge is positive and lepton number is negative, so this has to be a positron. Electron charge. Muons carrying our atmosphere are secondary products from high energetic cosmic ray interactions with the nuclear atmospheric particles. In their own frame, muons have a mean of that, with some lasting after that. The speed of muons from moving in a direction is in the range of that. Use non-relativistic physics to calculate the mean distance muons moving at 2.1991 times 10 to the negative 8 travel. So mean lifetime. So S is equal to 2.991 times 10 to the power of 8. And now I'm just going to use the mean lifetime, which is 2.2 times 10 to the negative 6. 2.991, 10 to the power of 8, and 2, 6, which is 658 meters. Calculate the mean lifetime muons traveling at that as observed from the Earth. So then T is TO divided by 1 minus V squared C squared. So this is 2.2 times 10 to the negative 6 all over square root of 1 minus 0.997. The C squares will cancel, so I'm just left with 997 squared. Now let's finish up that square root. And then I'll just put all of these in the calculator. Now I get 2.84 times 10. 1, 2, 3, 4, 5 to the negative 5 seconds. What is the actual mean distance traveled by such muons through the atmosphere as observed from the Earth? So then now S is equal to 2.84 times 10 to the negative 5. Such muon, so we use the 0.997 C again, so times 3 times 10 to the power of 8. Negative 5 times 0.997. So this would be about 8.8494 meters, or about 8.49 kilometers. So 8.49. Using this information, explain why a small number of muons reach the Earth. Due to some muons have a longer, what do they call it, lifetime. And the mean, so we'll be able to travel further than 8.49 kilometers, possibly a small few. With the longest lifespans. times 10 to the negative 6 seconds, or let's just do 3.0 to negative 6, 0.97. Time and travel faster. Their own time in their own frame. Some of you have the longest lifespans of that, and travel the furthest. Which is 0.9, 2.997 times 10 to the power of 8. Experience enough time dilation as observed from Earth to travel the full 10 kilometers to the surface. Explain why these muons reach the Earth from the perspective of the muons. So let's say using full or longest or max lifetime and fastest speeds, the length is equal to 10,000 square root of 1 minus, wait, hold on, so let's say that 2.997 times 10 to the power of 8 is 0.999 c. It's proper length 1 minus v squared c squared, and length we can say is 10,000. 1 minus 0.999 squared, which is only 447.1 meters, and then s equal to, so they can travel at 0.997 times 10 to the power of 8. What do I mean by these muons? Can I just use any of these? Some nasty for all two. Okay, and then attempt to accelerate times 3.0 times 10 to the negative 6 times 3 times 10 to the negative 6, and this is 899.1 meters. As L is less than S, then the muons can travel the distance. The length contracted distance in the proper time lifetime So traveling at relativistic speed, hence distance to surface is contracted. Two spaceships containing a Dees and Harper traveling towards each other. They are observed by a person on Earth to be traveling at the velocity shown in the diagram. Take all velocities to the left as positive. Calculate the velocity of Harper as measured by ATAR. So we can say that u dash is equal to v minus u, no, v plus u all over 1 plus vu c squared, because this is a velocity addition problem. Damn it, it is u minus v. U minus v, uv. Okay, so then u is Harper, so 0.75 c minus, and then my velocity, since we're going to the right, it's going to be negative. At the ATAR is negative 0.5 c, and this will all be over 1 minus 0.75 negative 0.5. So 0.75 plus 0.5, 1 plus 0.75 is 0.5. So this is 0.909 c. They already have C there. Get rid of that. Harper fires a missile with the velocity of 0.6 c with respect to her in the direction of Adida. Calculate the velocity of the missile as observed. Direction. Calculate the velocity of the missile as observed by an observer on Earth. So now u is going to be equal to u plus v all over 1 plus uv c squared. Wait, no, this one. So then in that frame of reference, it's going at 0.6 c. And then Harper is moving at 0.7. If you got the c, 0.6 c plus 0.75 c. All over 1 plus 0.6 times 0.75. 1 plus 0.6 times 0.75. So then, as measured by Earth, it's 0.931 c. 0.931. Calculate the velocity of the missile as measured by ATAR. So then we're going to have u is equal to u minus v all over 1 minus uv c squared. Now the u is going to the left at 0.931 c, and then ATAR is going to the right at 0.5 c. So then this will be 1 minus 0.931 negative 0.5. So then 0.931 plus 0.5, 1 plus 0.931 times 0.5, 0.974 c. This is quite generous that they're giving 12 marks for all of these questions. Okay. A group of physics students made a simple AC generator in class. It had 150 turns of the wire in 6 centimeter wide square coil. Was placed in a magnetic field of that. They connected to which rotated and used electricity produced to power the light globe. Calculate the maximum EMF produced by the generator. Okay. So pretty straightforward. This just made me start thinking of what is the thing. So there's the carbon rod. And then there's the split rings, or the slip rings, and slip rings. Slip rings make AC current, and the slit rings make the DC, because that's when they reverse, I think. Yes. Yeah, DC motors use the slit ring, so then they keep it. Okay. Sorry, anyway, I'm back. So E max, I like these questions where it's just put in the values, is equal to 2n 2 pi n BAF. Now it's 2 pi had 150 turns times 150. And B is 1.85 times 10 to the negative 2 millitesla, so this is going to be 0.185, because that's 185 millitesla, and divided by 1,000, that's 10 to the negative 1. My area is 6 centimeters wide, so 0.06 squared. Yes, and then frequency, I connected to the handle, motor which rotated, handle to a motor which rotated it at 240 RPM, so 240 rounds per minute. So rounds per second, that will be equal to 4. Frequency is 240 over 60, which will be equal to 4. So this is all times 4. So 2 pi times 150 times 0.185 times 0.06 squared times 4 hertz. So my maximum EMF is just 2.51 volts. 2.51. Calculate the RMS voltage produced. So ERMS is just E max all over the square root of 2. So 2.51 square root of 2. Square root of 2 is 1.77 volts. And then the students remove the motor and turn the handle themselves, maintaining a constant speed of rotation. They noticed that the force required to turn it varied as the coil rotated. They also noticed that the bulb glowed brightest when the force required was the greatest, and went out when the force required was virtually 0. Explain why the force required varied as the handle went through one rotation. So force required varied as the handle went through one rotation. As the handle went through the rotation, the perpendicular area perpendicular area let's just say maybe the theta between the magnetic field or the magnetic flux lines and the plane of the rotor. Should I say the rotor? Of the wire cutting the magnetic flux lines hence as magnetic force is going to be equal to ILB sine of theta. As theta varies, so too does the magnetic force experienced by the conductor. Therefore, to maintain a constant speed of F net equals 0, the required applied force must match the changing or the varying magnetic force so too does the retarding magnetic force. Match the varying magnetic force. Tell the handle themselves, move the motor. This is a generator. So F equals that. Perpendicular. So I just need to add the angle. Conductor length. Okay. Magnetic force vary. So your magnetic force is going to be changing. Should I talk about EMF? Maybe some back EMF. Should I change this answer to back EMF? I think I should. So as you apply it, there's a back EMF. Okay. So I think, yeah, let's get rid of this. Let's delete rotation. The square coil undergoes changes in magnetic flux. And then as the theta dt proportional EMF, this induces a back EMF this induces an EMF. I would say an because back EMF is for motors, not generators. In such a direction as to oppose the motion that created it. And dot E, a retarding magnetic force is created. So a retarding magnetic force is created, and therefore as the theta dt varies with the angle, between the slope coil and flux lines, so too will the EMF, and hence retarding magnetic force. Thus, force required by students to maintain constant speed which will be F net equals 0. Or no, constant speed. Constant speed will need to vary to match retarding magnetic force. In what position was the plane of the rotating field relative to the plane of the rotating coil relative to the field when the light bulb went out? The plane would have been perpendicular to the field at this point. The theta dt is at a minimum. Hence, induced EMF is at a minimum, therefore light bulb goes out. I'm going for a max to only slightly below it. This point, perpendicular area is maximum. So the change in magnetic flux is going to be a minimum. Okay, a satellite is orbiting Earth. Move over the surface, calculate the period of the satellite. So that's CT squared the radius is going to be equal to 4 times 10 to the power of 3, actually times 10 to the power of 6, plus the radius of the Earth. Radius of the Earth is 6.37 times 10 to the power of 6, which is going to be equal to 10.37 times 10 to the power of 6 meters. We know that t squared over r to the power of 3 is going to be equal to 4 pi gm. So we know that t is going to be square root of 4 pi times 10.37 times 10 to the power of 6 square to the power of 3 over 6.67 times 10 to the negative 11 times, where's the mass of the Earth, 5.97 times 10 to the 24. So this will give me the time in seconds times 10.37 times 10 to the power of 6 power of 3, 6.67 times 10 to the negative 11 times 5.97 times 10 to the power of 24. I'll do something wrong. I get that the period is only 5932.3 seconds. 60, which is minutes, hours. It's only 1.65 hours. Let me do that again. 4 pi times 10.37 times 10 to the power of 6 to the power of 3 that's 5.97 times 10 to the power of 24. Yeah. So 1.65 hours. Graph shows the relationship between t and the orbital radius r. Reference to the word to describe how a straight line graph could be generated using the same two variables. Do not refer to logarithms. Just do plot. Do t over r, so you want square root of t versus third root of r, because then those will be constants and that will be consistent. Explain how to use the gradient of the straight line in Kepler's third law to estimate the value of the rotation constant. Gradient equal. Oh wait, no. I should actually plot t squared versus r to the power of 3. Not the other way around. Because then the gradient would be a constant, which would be equal to Third's law. Gradient is equal to t squared over r power 3. But t squared over r to the power 3 is equal to 4 pi over gm. And big G would equal t squared over r to the power 3 times m over 4 pi equal your gradient times m over 4 pi. How many pages are there until section 3? So I'm on page 30. I'm on page 23 right now. Okay. A cable has a 6 meter long drawbridge with a mass of 500 kilograms over the moat. It is attached to a winch by an extremely strong rope at an angle of 35. Calculate the tension of the rope when the drawbridge is just lifted off the rest of the other side of the moat. So the drawbridge is just lifted off the rest. So take moments around O. I think I'll just finish this question off, and then I'll hop off. So take moments around O. So we're gonna have the mass of the drawbridge. So it's gonna be 6. So anti-clockwise moments equals my clockwise. Anti-clockwise moments. It's going to be the drawbridge tension. So we're going to have some force of tension up. So force of tension sine of 35. And radius will be 6. So 6 sine of 35 is 3.441. Force of tension, and then clockwise would be equal to just downwards, which is 500 times 3. A little bit to calculate for the radius. Just sine of 35. Anyway, clockwise is 9.8 times 500 times. Because there I was finding the perpendicular component of the tension force, but remember you can also find the perpendicular radius to there. That's sine of 35, which is force of tension times sine of 35 times 6, which is equivalent here. Yeah, and then this will be times 3. So 14700 Newton meters. So 14700 equals 3.441 force of tension. 3.441 is 4272. 4.27 times 10 to the power 3 newtons. Reaction force on the drawbridge at this point. So we'll say that the force is equal to 0. Vertical. The sum of the forces is simply the 500 minus 9.8. And then I'll do sine of 35 times 4.27 times 10 to the power 3 minus, so I'll do down is negative, minus 500 times 9.8. So I get negative 2450.8 newtons. Therefore, force of reaction is going to be vertical is 2450.8 newtons up, and then horizontal plus force of reaction. And sum my forces x and y going to be vertical, horizontal. It's going to be only the tension, so cosine of 35 times 4.27 times 10 to the power 3 minus plus force of the reaction. So cosine of 35 times 4.27 times 10 to the negative 3. Let's just say here. Horizontal, vertical force reaction horizontal is 3497.8 newtons to the right. So then we go boom, boom, 3497.8 and 2450.8. We'll call this theta, and we'll call that f of r. Tangent negative 1 over 3497.8. .0 degrees, and the magnitude of it square plus 2450.8 square is 4271. So then, what the heck? Huh. That's funny. It's the same. 4.27 times 10 to the power 3 at 35 degrees to the horizontal. See, the castle comes under attack. The people inside the castle begin to raise the drawbridge. When it comes at an angle of 15 degrees above the horizontal, the angle between the drawbridge and the rope is 40 degrees. At this moment, the 95 kilogram soldier begins. When Chase jumps into the very end of the drawbridge, can calculate the new tension in the rope as he hangs from the end. Assume the drawbridge is stationary at this time. So here's my P. That's 15 degrees. And this is now 40 degrees. And it was 6 meters long. So this is 40, and this full thing here is 6 meters. Okay. The angle of these are going to be 75. So take moments around P. And again, somebody anti-clockwise. Equal to the sum of the clockwise. So the anti-clockwise moments is going to be sine of 40, or 6 times sine of 40 force of tension. Because my perpendicular radius is 6 meters, that hasn't changed. All that's changed is now my angle from the drawbridge to the rope is now 40 degrees. 6 sine of 40 is 3.857 force of tension. So anti-clockwise is going to be 3 times sine of 75 that would be cosine of 75 actually. This is my force of my weight force. Oh no, because that's what I want, isn't it? Yeah, so sine of 75. What I want is either the perpendicular radius, which is going to be sine of 75, or I want the perpendicular force, which if I make that a right angle, that's also going to be 75 degrees. If I match these up, that's 75, and then that's my perpendicular force to the radius. So yeah, sine of 75. Because then that would be my hypotenuse. So sine 75 times 9.8 times 500 plus 6 times sine of 75 times 9.8 times 95 kilograms order. 95. So sine of 75 times 9.8, 3 times 500 plus 6 times 95. So 19,595 Newton meters. So then 19,595, 3.857 F of T. Force of tension then equals 19,595 by 3.857. So I get the force of tension now is 5.08 times 10 to the power of 3 newtons. Okay, I'm going to stop it here, and I'll come back later and finish the exam up because I got swimming now. So yeah, later. We're back. I just came back from what I was doing, and I've had dinner now. I just need to check that my timer is aligned properly. Okay, so I got the articles up for comprehension, so I won't need to spend time getting those up. So hopefully from here it's all nice and smooth. So let's continue. The equation. Graph the rotational velocity versus distance on the set of axes provided below and draw a line of best fit. Do not take your line through the origin. Okay, this is really ugly. So 6.96 and 0.45. So 1, 2, 3. So each of these is 0.5, I assume. So then it was 6.9. So we'll pretty much just go to the 4 about there. And then you go 0.45. And each of these is 0.05. 0.45 is probably about there. The next one will be 11.9. So again, 11.9 and 0.88. 11.9 and 0.8 and 0.75. 8, right about there. Maybe a bit more to the right. And then 17.9, so we'll take it as 18, and then 1.46. So 18, 16, 17, 18, 1.46. About there. And then 24.7 and 2.19. 24.7 and 2.19. Wait, no, about there. And then 31, 2.82. So I do 31, 2.82. That's 9. That's 8. So about there. Okay. And draw a line of best fit. So let's make these points a bit bigger, a bit fatter. Up there. And there. Okay, now we can take this. And then... Oh, I don't want 45 exactly, come on. Guess a strict 45 isn't too bad actually there. Okay. And then we'll just bring this down as well. The wrong pen. Alright. Use two non-data to calculate, circle the 2 points and give your answer to two significant figures. Calculate Coble's constant. So we'll say 5 and 0.2 to, so I use that point, and then we'll go all the way up. Let's say this point, which is about 32.5, and 2.95. 2.5, 2.95. So then m is equal to 2.95 minus 0.2. So my m is 0.1. Oh wait, megaparsecs. So m is equal to velocity over d, then ho, and HOD, velocity over d, so then HO 0.1, so no, 0.10. Calculate Hubble's constant. Do I need to do any? No, I don't think I need to, because these units are exactly the same units as above. So I don't need to be doing any conversions. So just 0.10, I think. 5 and 0.2 is 32.5, 2.95 here. Yeah, I mean, not sure what else to do really, so I guess I'll just leave it like that. The galaxy is to always convert this distance into megaparsecs. So we'll just bring up the conversions. 1 megaparsec is equal to 3.262 centiparsecs. So then is 7.42 times 10 to the power 7, 3.26 times 10 to the power 6, 2.6 times 10 to the power 6, 22.8 megaparsec. Using the line of best fit and the value, calculate the observed redshift wavelength emitted from if lambda is 840 nanometers. So then delta lambda is going to be equal to lambda OV over C, and velocity .8 megaparsecs. V is equal to 22.8 times 0.1 times 10 to the power of 3. So 280 kilometers per second. Now it looks like this has to be in meters per second. So 10,000 is 2.80 times 10 power 5 meters per second. So then my change in lambda is going to be 840 times 10 to the negative 9 times 2.8 times 10 to the power 5 all over 3 times 10 to the power of 8. 40 negative 9, 2.8, 10 to the 5, and then 3 times 10 to the power of 8. It's going to be tiny. 7.84 times 10 to the negative 10. So we're going to have 840 times 10 to the negative 9 observed. And that is going to be equal to 840 times 10 to the negative 9 plus 7.84 times 10 to the negative 10. So it's 841 times 10 to the negative 9 nanometers. So we went up by 1 nanometer. I'll pause after putting my timer. Okay, we're back. Just make sure everything's correct. So 22.8 megaparsecs. Power 7, 3.26, 10 to the power 6 is 22.8 megaparsecs. 0.1. So that's saying about 100 kilometers per second per megaparsec. I think the accurate value is 70. I think 0.1 is reasonable. And 22.8 times 0.1 times 6,000. Oh wait. Yeah, I think I missed a 0 here. 2280. 0.1 times 10 to the power 3 kilometers per second. Yeah, I missed. Looks like I messed up quite a bit. 1 times 1,000 is 22.8 times 10 to the power 6. 1, 2, 3, 4, 5, 6 meters per second. So then this will give me 3 times 10 to the power 8. which is 606.38 times 10 to the negative 9. And then we're being red shifted, so we're adding this wavelength. So that's going to be 46. Times 10 to the negative 9 meters, 46 nanometers. Okay, in Hubble's earlier data, he noticed that one particular spiral galaxy close to Earth, seen edge on, had two values of V at its extremes. One was positive, one was negative. So we just want to explain how this could occur. This could occur if the galaxy was rotating. Rotating, hence, when viewed side on, when viewed edge on, one side would look as if it was coming towards Earth. The other as if it was going away from Earth. Heading away from Earth. Also, as galaxy is close to Earth, its cosmological, its velocity, its recessional velocity will be low. Low, let's say low enough so that velocity of rotating arm toward Earth is greater than recessional, thus appearing as it's coming towards Earth. Therefore, the galaxy has one side that looks like it's coming towards, or has, therefore galaxy, oh wait, sorry, I'm not supposed to use 3 dots in WACE exams, so I'll say, therefore, galaxy has 2 extremes moving in opposite directions. Relative to Earth. They're far, no 3 dots, hence their velocities will be opposite sides. We have opposite sides. say here circular velocity, rotating side, circular velocity of rotating side towards Earth, greater than recessional. Okay, end of section 2. 20 cyclotrons. Okay. A cyclotron is a particle accelerator. It is an electrically powered machine that produces a beam of charged particles that can be used for medical, industrial, and research purposes. A cyclotron accelerates charged particles in a spiral path, which allows for a much longer path for acceleration than a straight line accelerator. A cyclotron consists of two semicircular charged plates in a flat vacuum chamber called Ds. Because of the shape, the chamber sits between the poles. The magnet creates a strong and vertical magnetic field. A stream of particles is fed into the center, and a high-frequency alternating voltage is applied across the plates. This voltage accelerates the charged particles across the gap every half turn. Combined with the magnetic field, this process causes the particles to spiral outwards until they exit the cyclotron. Okay, I'm going to bring up the first image, which is from, I think, this one. Okay. So then square wave electric field accelerates charge at each gap crossing. The cyclotron frequency how often the electric field between the D's reverse are independent of both the velocity of the particles and the radius of the circular path they follow. Medical cyclotrons. Medical cyclotrons produce proton beams that are used to manufacture radioisotopes used in medical diagnosis. Radioisotopes produced in a cyclotron decay by either positron emission or electron capture. Positron emission tomography (PET) and single photon emission computated tomography, which SPECT, which uses gamma ray emission, are two imaging techniques that rely on cyclotron-produced radioisotopes. The diagram above shows the acceleration of a positive particle in a cyclotron. Describe one change that needs to be made in order to use the same machine to produce a beam of negatively charged particles exiting from the same place. Explain why. So negative would accelerate in the opposite direction. So electric field frequency needs to so let's say alternating current needs to be reversed. To have the voltage accelerates and the high frequency alternating voltage is applied across the plates. Accelerates the charged particle. Across the gap every half turn. Maybe I just need to talk about magnetic field needs to be reversed. Negatively charged particles experience a magnetic force opposite that of a positively charged particle when in the same field. Therefore, to have the path so hence to have for magnetic field to control path of negative particle correctly, it needs to be reversed. must what do you say, must flow in the opposite direction when compared to a positive particle. Okay. Question 2. Positrons are examples of antimatter and have the same properties as electrons, except for having a positive charge. When they collide with an electron, the following process occurs. Calculate the wavelength of the photons produced in the annihilation, described in the diagram below. So the wavelength. So E equals hc over lambda. So lambda is equal to hc over E. Is equal to 6.63 times 10 to the negative 34 times 3 times 10 to the power of 8 all over 511 times 10 to the power of 3 times 1.6 times 10 to the negative 19. Long for the day where I don't have to write 6.63 anymore, especially in an exam. I feel like we should be able to just not write it because, I mean, they're constants, they're not going to change. So if we get a wrong answer out of using them, it just means we had a calculator error. So 3 times 10 to the power of 8, 511, 6 times 10 to the negative 19. I get a 2.43 times 10 to the negative 12 meters. So 2.43. Oh god. Times 10 to the negative 12 meters. Kilo electron volt photon. To which part of the electromagnetic spectrum does this photon belong? Well, if the wavelength is that small, this is definitely gamma rays. I backspaced there, or I reversed it to like try and make it a capital R, but then I just didn't write a capital R. Explain why increasing the strength of the magnetic field will increase the velocity of the particles leaving the cyclotron. Strength of the magnetic field. Increase the velocity of the particles leaving the cyclotron. So then we know that R equals mv over qb as magnetic field increases. And we're back. My sister just came in to show me something. Okay, so why explain why increasing the strength of magnetic field increases the velocity of particles leaving the cyclotron. So bends. These have a set. Okay, so these have a set. These have a set R. Set radius. Therefore, R is constant. And then I'll say M and Q of particle also constant. Thus, as B increases, V must also increase to counteract the change. That's good. B increases. We're back again. My mom came in this time. Have a set radius and leaving point. For R is constant, B increase. It's also increased to counteract. It's also increased to maintain a constant explain why the voltages across the Ds must alternate. So that the particles are in constant acceleration that is constantly experiencing a repulsive force behind them, and the attractive force in front of them. Experiencing repulsive electrostatic, attractive electrostatic. This can only happen if the voltage on the D's alternate when the particles have passed through them. Pass a D. Just past each gap. Because they accelerate every half turn. The voltage accelerate every half turn. Yeah. Constant positive acceleration. Otherwise, the acceleration of one half turn will become the particle the next half turn. Okay, the cyclotron frequency is independent of both the velocity of the particles and the radius of the particle path. Derive an expression for the cyclotron frequency and use the expression to explain why this statement is correct. Okay. Frequency. Derive an expression for the cyclotron frequency how often the electric field between the D's reverses. So the voltage accelerates across every half turn. So every half turn it needs to flip. frequency is going to be equal to half of 2 pi r, because that's going to be the circumference, and it's only doing half of it. And then divide it all by velocity. So that's going to be pi r over v. So then this is going to be pi mv qb all over v. So this is pi m over qb. Wait, no. Frequency is equal to 1 over time. Over t is equal to 2 pi r over v. Okay, here we go. Now I'm cooking. But F is about voltage flips every half turn. Therefore, T, I say hence, required T is equal to pi r over v. So then frequency is going to be the inverse of that. So velocity over pi r. And this is going to be velocity over pi times mv over qb, which is going to be equal to vqb all over mv pi. So it's qb all over m pi as r and velocity are not in the equation. Frequency of cyclotron, so we can say cyclotron frequency is independent of r and v. I think that's so good. Okay, now onto wind turbines. Okay, so it looks like I have to read the first, I think it's the first 2 paragraphs of this. And then this was just an image. I couldn't get one of the other images up because it wasn't working. We'll see. So, wind turbine blades rotate when they hit by the wind, and this doesn't have to be a strong wind either. The blades of most wind turbines will start turning at wind speeds of 3 to 5 meters per second, which is quite a gentle breeze. In this spinning motion that turns a shaft and nacelle, which is the box-like structure at the top of a wind turbine, a generator built into the nacelle then converts the kinetic energy of the turning shaft into electrical energy. This then passes through a transformer which steps up the voltage so it can be transported to the national grid or used by a local site. Okay. So A1, explain why a step-up transformer is used to increase the voltage before transporting the electricity into the national grid. Use specific equations in your answer. So, a step-up transformer will step up transformer will increase the voltage of equals P loss, actually known as voltage equals IR. When voltage increases, wait, no, P equals, right, so then I'll say here P equals VI. When voltage increases, power must remain constant. And so hence I will decrease. And we can say, but P loss equals I squared R. Thus, when I decreases, and then here I'll say R is constant for a given line, then P loss also decreases. Hence, increasing voltage through a step-up transformer decreases the power loss experienced due to the resistance in the wiring. Now the other one is P equals V squared over R, but I'm pretty sure this is actually secretly delta V squared. So yeah, calculate the output voltage of a transformer if the turbine produces 690 volts and the ratio of turns is 100 in the primary and 2,500 in the secondary. So VP VS is equal to IP, oh sorry, not I, NP NS. So then voltage in the secondary is going to equal NS VP for NP. So the number in the secondary is 2,500 all over 100 times 690. 2,500 divided by 100 times 690. So 1.73 times 10 to the power of 4 volts, which is going to equal 1.73 times 10 to the power of 1 kilovolts. With specific reference to the text, explain why the pitch of the rotor blades is changed by the operators of the turbine. So I have 2 pages left. Wow, we finished this exam early. So as pitch talked about here, wind turbine blades vary in length between 40 and 80 meters. A major problem with wind turbines is varying wind speed. The input power must match the output power. The output power depends entirely on rotational speed and torque. So how do we keep rotational frequency constant when wind speeds keep changing? The solution is mechanical. The operators use blade pitch control, which changes the angle of the blades and reduces the surface area facing the wind. This reduces the amount of energy collected by the turbines and controls the force applied to each blade. The input power must match the output power. The output power depends entirely on rotational speed and torque, so how do we keep rotational frequency constant? When wind speed's changing, solution is mechanical. Okay, so we talk about change pitch of blades is changed to change the angle of the blades against the wind. Change the angle of the blades, hence reducing, or maybe I say hence changing surface area of wind against the blades. This allows for control on the amount of applied force on the blades hence allowing the operators to maintain a constant rotational speed, hence rotational speed / frequency, ensuring that the output power is constant, matching the input power. To maintain a constant rotational speed / frequency despite changing wind speeds. And the blades by the wind. Despite changing wind speeds. And why is this desired? It's varying wind speed. The input power must match the output power. So a generator built converts the kinetic energy of the turning shaft into electrical energy. What does it mean by the input power must match the output power? Hence the generator in the nacelle can output a consistent we'll also have a constant rotational speed. I'm just going to say this blankly so that input power matches output power. Maybe I'll say here wind turbine blades spin as wind hits them. Let's put that at the start. Okay, I'm just going to move on. If the 60-meter long blades on an average size were rotating at 0.2 Hertz, estimate the speed of the center of mass of one of the blades. Hmm. $60 meters long. And the center of mass, is it going to be halfway up? Probably won't be, right? Maybe a little back on the inside. Center of mass. So let's say assume center of mass. It's 25 meters from rotating from hinge. So 60 meters long on average, the rotating is 0.5. Estimate the speed of the center. So then 0.25 Hertz, so time is equal to 1 over 0.2, 35 seconds. So then velocity is 2 pi r over time, which is 2 pi times 25 all over 5, which is, that's going to become 5, so it's going to be 10 pi, so 31.4 meters per second. Speed of the center of mass of one of the blades. O times pi times 25 over 5 is 31.4. Yep. Consider the 3-blade turbine in the diagram to be rotating clockwise. The blades on the left hand side is parallel to the ground. The blades are identical in size and mass. Draw the weight forces acting on the blades. Parallel to the ground, so then this one will be like here for G. Let's see, how big did I draw that? About 3. So I need to find the midpoint of here, which is about there, I think. And you go 1, 2, 3, and then the midpoint of this guy, probably around there. And then I go 1, 2, 3. Let's see. So that's 3 a bit. Let's say a bit more. About there. And then this guy is fine. So yeah, pretty happy with this. FG. And then FOG. Show mathematically that the turbine is balanced in this position. Oh, okay. This is interesting. Rotating clockwise. And this guy's parallel, so that's going to be a 90-degree angle. Let me draw some lines here. Let's say this line, and let's say this line. Okay, that's 90, and this has to be 120, so this must be 30. So then this angle here, if I drew like that, that's 30 degrees. So the perpendicular radius of all of these is going to be the same, but here and here, because that's going to be 90. No, this is going to be 60. Perpendicular force there. It's going to be 30. So let's take moments around hinge, or P. So moments around hinge slash P, and we'll say that the anti-clockwise moment equals the sum of the clockwise moments. Now the anti-clockwise moments is just this guy, f of g times r perpendicular. R perpendicular draw it like this, and you can say that this is a right angle triangle. Wait, I drew that parallel and did that. I do it like that, and since this has to be 90 degrees, this has to be 60. So then that's 60 cosine of f of g. But then here, it's going to need to be like that. And since that's 90, no, sorry, I don't want that to be 90. Wait, no, let's say that's 90, because that'll be my perpendicular force. Is same for all turbines, and then sum of the clockwise is going to be, so this force here is Fg cosine of 60, and then this force here, that's the 90 f of g, and let's say I have a parallel line there to that, so this is now 90 as well. Then this will have to be 30, so then this is 60. So then this is also Fg cosine of 60. I think. What's Fg cosine of 60, guys? Yes, it's a half. Okay, now we're cooking. Now we're getting somewhere. Because what happens is that this angle has to equal this angle, because we have the same line cutting through here, and then they're both against a horizontally straight line. So I know that that angle is 30. And since I know that this angle has to be 90 for it to be the perpendicular force, this angle here also has to be 90 because it's on a straight line. So I know that this angle here has to add up with this to get 90, so that has to be 60. And then since I drew this as my perpendicular, and because this is my parallel, and this is perpendicular to that, so that has to be perpendicular to this, so that's 90. So then here I can just do cosine of 60 is equal to, let's say, x over f of g, and f of g equals x equals f of g cosine of 60. Okay, right? So then anti-clockwise is equal to r perpendicular times fg cosine of 60 plus that times fg cosine of 60. So then, which is equal to half of r theta, because cosine of 60 is a half, f of g plus a half plus f of g is going to be 1, which is just fg times r perpendicular, which is equal to the anti-clockwise moments, as anti-clockwise moments equals the sum of the clockwise moments. Then the net torque is 0. Then net torque equals 0. Hence system is balanced. Hence system is balanced. Okay, I think I'm going to end it there because that was the end of the questions. So it's time to mark now. I think that assumption is fine, as long as it's closer to the hinge, maybe 5 meters. Okay. But yeah, okay, I'm gonna go mark this exam now, so I'll be back later. And we're back, people. Time to go through the marking. We got 91.9%, which I think is a new highest WACE score. Well, that I've done on camera. I got a 93 for the 2016 WACE that I did on paper. But on camera, where you've seen everything I've done, I got 91.9%. I think that's the highest. I don't know. Can't be bothered to check. So we lost 3 in section 1. We lost, which is actually a bit more than I thought we would. I thought section 1 was quite easy. We lost quite a few. 7 in section 2, and then 5 in section 3. But a lot of those marks were just in one question, which we'll see when we get there. So let's go down. We did these graphs correctly. We calculated all of these things correctly. All of this was correct. The first thing that we got wrong was here, where it wasn't really that we got it correct, we just didn't talk about it. We just had to say that aluminum is a conductor, which I mean is fair, I guess. I can't use this explanation on wood because wood isn't a conductor, so that wouldn't make sense, so I have to talk about its conductor. That's the first mark lost. The next mark here that I lost is I needed to talk about why or how these are constructive or destructive, and for that you need to talk about in phase and out of phase. I didn't talk about that, so I knocked the mark there off. It was just 1 mark for talking about this for both of them, luckily, otherwise I would have lost 2. So I got 1 mark for talking about the fraction, 1 mark for talking about interfering with each other, and then 1 mark for talking about constructive being bright fringes and then destructive being dark fringes. So, and then the last mark, word for word verbatim, is when the 2 waves are in phase, constructive interference. When the 2 waves meet 180 degrees out of phase, destructive interference. So we'll talk about phase. It's just another mark. So that's another mark we lost. Down. Oh yeah, for this question, you could have talked about this just being A equals C, then B equals 1, or the approach is 1. I didn't really talk about B, but I mean, I talked about the relationships correctly, so I gave myself the marks there. And then here, 6.5. They only did it to 2 significant figures for some reason, which is a bit odd. But yeah. Here, A was correct. Here, I just didn't get this correct because my mass is only 1 kilogram, because I'm talking about the 2 kilogram exerting on the 1 kilogram book. So that was just a little mistake. I had the right idea, so I only knocked 1 mark off there. You got 2 marks for adding weight force to the net force to get total force. So I thought 1 mark for the correct equation, which is the one that they showed. But then I knocked a mark off for here because that's wrong, and then I gave myself a follow-through mark for a consistent answer. So yeah, this isn't the acceleration or the net force of the 2 kilogram, it will be of the 1 kilogram. So I was nearly correct, where I had to oppose the reaction force or the weight force, oppose the weight force with a reaction force, and then also give it its additional acceleration. So we lost another mark there. I'm gonna need to sneeze in a second. That's me sneezing. So yeah, we lost the 3 marks there. First mark we lost in section 2 was a bit further down. I actually did quite well. Here, I don't know what happened here. Must have been a calculator error. Let me see if I can figure out what happened. Yeah, I have no idea what happened. Because when you put this in, it is 0.976. I don't know how it goes 0.974. Oh, maybe because the 2 more decimal places is 0.9764. So maybe I took that 4 from the 4th decimal place instead of the 6th that I should have. But yeah, so I lost the mark there, obviously. Everything else was correct. So that's 1 mark we lost. Down. EMF stuff was all good. Here you needed to talk about light for some reason, even though there's no mention of light in here. I get that they talk about the light in the info, but there's no mention of like discuss light, discuss the forces relevant when the light is on or off or whatever. But the light will be brightest when the EMF is the greatest. Hence, the retarding magnetic force will be greatest. So that's why the force required was the greatest when the light was the brightest. And here was fine. Here I should have talked about, instead of saying a minimum, I should have said 0. And then again here, instead of saying EMF is at a minimum, I should have said just at 0. But I thought close enough. I mean, the minimum is 0 because we're at a maximum. So I gave myself full marks there. So that's another mark we lost. Here I lost a mark because of my equations. I didn't square the pi for whatever reason. I think I was looking straight at it on the formula page and I didn't square it, which becomes a problem in the next question too. So that's another mark we lost. But I gave myself follow-through marks because the marking key for this one was, let me find it. I need to go down a bit. You got 1 mark for converting kilometers to meters, and you got another mark for adding the altitude to the radius of the Earth, so there's 2 marks there. You got 1 mark for cubes, distance, and squares roots answers, so that's kind of the mark that I decided to not give myself. And then I decided to give myself a follow-through mark for a consistent answer with whatever I put in here, and then a consistent converting to hours. So lost 1 mark. So going down here, I didn't talk about Kepler's third law, because if I did, then we'll look at the second mark. You got 1 mark for stating that t squared is proportional to r over 3. So then I got the mark for saying graph or plot t squared versus r to the power of 3. But yeah, I mean, plotting this to get a straight line strongly implies that they're proportional. But whatever, so that's another mark. And then here I lost 2 marks because I said that the gradient was t squared over r to the power 3, which is correct. Over here again, I didn't square the pi for whatever reason. And then I also rearranged wrong, because if the g is at the bottom here, then this is actually 1 on g, so I had to find the reciprocal of it, which you'll see here. So then it's actually 1 on top of the gradient. 1 on top of gradient times 4 pi squared over m. So here's where you get your second mark. And then your third mark would be for saying that m is constant, therefore g can be calculated. So I only got 1 mark there for stating that the gradient equals that. And then, so I lost 2 marks there. All of this stuff was good. Going down, going down, going down. I lost 1 mark here because I didn't read from the graph. I decided to not give myself the mark because it does clearly say use your line of best fit, which I didn't do. I just used the equation. But what they wanted you to do was, since your distance is 22.8 megaparsecs, that's 21, that's 22, so 22.8 is probably about here, then you would come here and you would use this value as your velocity rather than the velocity of through the equation, which is what I used. So yeah, I lost 1 mark there. Going down, that was fine. So that is our 8 marks that we lost, which is I think, wait a minute. Let's count up the amount of marks we lost in section 2. So section 2 problem solving. So we lost 1 there, 1 there, 1 there, 1 there, 2 there, and then 1 more down here, right? 1 there, and that was it. Yeah, okay, we lost 7. Never mind. Must have put a 1 again twice. Here, this was good. Magnetic force reversed. All of this was good. Here was a bit annoying. I lost 3 marks for this question because what I wanted to say, or what they wanted me to say, was that as B increases, R decreases. So then R decreases. So then number of revolutions before exiting increases. Before exiting increases. Hence, more acceleration from passing between these. Passing between these, hence, from passing between these, therefore, velocity increases. Oh, not arrow. Velocity increases. So I only got 1 mark for stating this. So you got a 1 mark for saying radius would decrease, 1 mark for saying that this would increase the number of revolutions, and then the final mark for saying that this would increase your acceleration, therefore your velocity would increase. Velocity increases when exiting. Okay. So I lost 3 marks there, and that was the only marks I've lost so far. I lost a mark here just because I just said that the plates need to be the opposite charge for the particles to be attracted to it. The plate opposite must have opposite charge for the particle to attract it. So I'll say, sorry, plate opposite to particle. Particle must have opposite charge to attract it, and I didn't say that, but the second mark, it says when the particle approaches the electric field from the opposite direction, the polarity of the field must change for the acceleration to remain positive. But that I did say. The voltage will alternate when the path has passed each half turn. Otherwise, the acceleration will decelerate for the next half turn. And then this question we got full marks for, which is very nice. I like this question. As it was very smart, very nice question. Approaching electric field from the opposite direction. Actually, I'm gonna add here better if when approaching electric field from opposite direction, polarity field must flip so that acceleration is positive. Okay, and then here again we got the full marks. Going down, I lost 1 mark here simply because I just didn't say that this increases efficiency. Apparently that was one of the marks. I got a mark here, here, and decreasing power, so there. Voltage increase, power must remain constant, so yeah. Current decrease, then P loss also decreases due to heat. I think was one of the things that they had in brackets as well. Power is lost as heat. Lower the current, the lower the power loss due to heat. Then, so I lost 1 mark there. Going down. I think the rest of this was all good. Here, you needed to talk about, or you needed to assume that the center of the mass is less than half of the blade length, which is 60, so it just needed to be less than 30, and I said 25, which is fine. They said 20, but the mark was for estimates the distance of center of mass from pivot as less than half of the length. So I mean, that's what I did. And then here, it was all correct. What they did though was that they said that this was 60 degrees, which it is. And then all they did was that they found the perpendicular radius like that, saying that this was R, and that's a 90. So then R perpendicular equals 60 cosine of R, which is a lot easier than all the angle finding that I had to do. But I still got the right answer, so it is what it is. Maybe instead of perpendicular, I should have said just R. Because it's not really the perpendicular, it's the perpendicular. It's the force that I was finding that was perpendicular. So really, I shouldn't have these perpendiculars. I should have said radius is the same for all turbines. And then perpendicular is whatever. But yeah. You had to just show that they were equal, which I did here. And then that was your final mark. So, bada bing, bada boom. Full marks. So I lost 5 marks there. So I lost 5 marks and 91.9%. Very nice. Hopefully next time it goes up a little bit more. So then I can start matching my average, which would be good for scaling and whatnot. So yeah, that's it. See ya.